So with the first one, we're deciding if it's corresponding pair or angles, corresponding sides, or neither. So we look at angle B, and we have one arc. And we look at angle H, and we have one arc. The arcs number match. So we can say that they are corresponding. Are they angles or sides?
Angles.
They're angles. So we call them corresponding angles. Our next group, we are looking at DB, segment DB, and segment HK. Segment DB. Right here, how many tick marks does it have? 1. Segment HK, how many tick marks does it have? Do they match? Nope, so we say neither. And then we go on to our next group. Complete the statement with the corresponding congruent parts. So angle J is congruent to which angle?
D.
So angle J is congruent to angle D. That is correct. They each have 2 arcs. So we put angle D. And then we have CB. Segment CB is congruent to which one?
HK.
HK. See, Montu, you could do it. Okay. Over here, then where the triangles are congruent, identify all pairs of corresponding parts. Then write a congruent statement. I'm going to write that up here. So we have corresponding angles. And we have corresponding sides. Okay, so corresponding angles. If I start with the one arc, I have angle B is congruent to which angle?
Wait, repeat that.
Angle B is congruent to which angle? Angle. Okay, angle D is congruent to which angle?
J.
Angle J. And angle C is congruent to which angle? I wrote. Angle C is congruent to? Angle K. Okay, now we're going to do sides. I start with the one tick mark. So we have side DB is congruent to side HJ. We have side DC, which is congruent to
KJ.
KJ. And last but not least, we have side, which is congruent to HK. Correct. Okay, now that we've listed all the corresponding congruent parts, we now have to make that statement of congruence. So triangle BDC is congruent to triangle HJK. Remember, we get these by going down right here. Us drawing marks in, I apologize. I will try to stay consistent in having using black as the color that I'm going to draw those lines in. The problem was that I did not have a way to do that on the computer. So I'm just going to draw them in here. You can add them if you draw the picture. So we see here. Okay, so this is the SAS Postulate. It stands for side, side, side. So the side, 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 or SSS, is if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the two triangles are congruent. So if 3 sides of one triangle are congruent to 3 sides of another triangle, it's going to be congruent. So here I have underlined 3 sides, 2 triangles are congruent. So again, I'm going to use the black pen to show. We have so SAS Postulate, if 2 sides and the included angle, so the key part here is that included angle of one triangle are congruent to the 2 sides and the included angle of a second triangle, then the 2 triangles are congruent. So you see we have 2 sides that are congruent, 2 sides that are congruent. The angle in between them is congruent with the one in the other triangle. That's what we consider to be that included angle. If that happens in one triangle with another, then both triangles are congruent. So, proof writing. So, how to write a proof? List the given information first. So, we're going to do that. Use the information from the diagram. You're going to look at your diagram and use the picture to make decisions. Give a reason for every statement. So, we've been building on this every lesson we've done. I want you guys to show me how you know it. Use the information, definitions, and postulates, theorems as reasons. So that is going to be your reason half. We list them in order, And then we end the proof with what we were trying to prove. So we're drawing those in. You guys have to label these again. Update it. Is to see if example A has enough information. Do we have 3 congruent sides? Do we see where that is? Do we have one pair of congruent sides? Do we have another pair of congruent sides?
No.
We have one more congruent side, and we see it right here. Both triangles share this side. So we can say that, but do we know that these 2 sides are congruent? Naya already told us no. There's not enough information, so we write no, not enough info. Our next one, we see that segment KH is congruent to segment KL. And we see that HJ is congruent to segment LJ. Do we know the included angle or a third side is congruent? We do. We see here that both of them share a third side. Since they share it, that's that reflexive property, and it is congruent to itself. So each of them have that same third side, which has to be the same length because it's the same side. So we know that, let me change my color here, that in each triangle here, KJ is congruent to KJ. Therefore, we are able to say that there is enough information to prove congruence by side, side, side. You don't have to write all this out, but I just want to make sure you can see it. So you can prove by side, side, side. Do you guys have any questions? So we could say that KJ was congruent to KJ by reflexive property. Do you guys need another second on this slide? Can I switch it? Okay, again, I have to draw on what was given in this problem. So if you give me 1 second, I will have that on here. So we have okay. Do you want a second to update your pictures? I'll give it to you anyway. Okay, so let's list what was given or seen in the photo. So we have that segment FE is congruent to which side? Yep, PRRP. Either way, we have segment FH is congruent to QP or PQ, yep. And then we have one more congruence. What do we have? Exactly right, thank you. Angle F is congruent to angle P. So, do we have enough information to see if these are congruent based on side, angle, side? We do. We have the 2 sides that are congruent, and then the included angle between those sides are also congruent. So, yes, we can use SAS. Okay, for B, we see that we have segment KJ is congruent to which one? Yep, LM or ML. We have segment KH. It's congruent to? Exactly right. And we have angle H is congruent to? Angle N. So it's the other one with just the one arc. So we see that this angle H is congruent to this angle N. Do we have enough information here to show that we can use SAS? So remember, we have two sides and an included angle. So is this angle included between those two sides? Nope. Over here, is that angle included between these two sides? No, so we cannot use it. As we write that in. So given segment SQ is congruent to segment PM. And, that's my and sign, angle SQM is congruent to angle PMQ. So this is given information. I just was not able to type it onto my slide. So please make sure that you add it to your notes. And we have triangle, our goal is to prove triangle QSM is congruent to triangle MPQ. So that is all given information from your problem. So that's what your problem asks for. And then I'm going to label our triangles. So S, M, P, Q, angle sign is congruent to this angle. Okay, so that would be what your question would be given when you got a question on a quiz or a test. This is what would be the starting point. You would be responsible for what comes next. So let's walk through how to write a proof. So we are going to start by making two columns. So we have statement and reasons. So every time you are starting a question that tells you to write a proof, you need to make two columns. One's going to be labeled statements and one's going to be labeled reasons. Our next part is we are going to then, our goal is to prove the proof statement, right? So ultimately we want to show the two triangles are congruent. And right now we have two ways of knowing how to do that. We have side, 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 and side, angle, side. So we want to figure out how to use it. So we're going to list the given information. So right now we know that segment SQ is congruent to segment PM. And that was given in the problem. So our reason is that it's given. So when you write this out, I am going to have to see these steps. So we're going to label that 1, 1. Step 2. We also are given the fact that angle SQM is congruent to angle PMQ. And that was also just given in our problem. And now we have to look at our picture. So we have to either use side, 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 or side, angle, side. So right now we have what?
SQ.
Yeah, we have SQ is congruent to MP, and we have these two angles are congruent. So we have a side and an angle. So what are we missing? Another side. So remember, it has to be the included angle, so there has to be a way for us to show that this is congruent to the same spot on the other triangle. Do you guys remember how we would do that? We talked about it in our last example. How do we show that this segment is going to be congruent to itself?
We don't have to show that they're lined up together.
So they're lined up together, but we have to have a reason for it. So you're right. We can write QM is congruent to QM. And we know this by that reflexive property. So back when we gave you that cut out of a paper, it told you the symmetric, transitive, And reflexive, that's where we're getting this from, so that reflexive property. And we say of congruence. So I'm going to draw that in with my red. We see here that by the reflexive property, MQ, segment MQ is congruent to segment MQ. So now we have side, angle, side, side, angle, side. So we are able to show that triangle. Let me use my black again. So step 4, we have triangle. And that's my proof statement. QSM is congruent to triangle MPQ. And we know that by side, angle, side. Okay, so now that we have the given information, this is what the problem would have asked. We would create this statement and reasons column. So that's our chart. So our first step is to look at our goal. So we want to prove that the two triangles are congruent. And then now we're going to have to show that. So our first statement is going to be showing what we know. So I know that AC is congruent to EC because it was given in the problem. I also know that DC is congruent to BC because it was, again, given in the problem. So when we look at this, we know something about these angles. What do we know about angle ACB and angle DCF or E? We know they're what type of angle? We know that they're right angles. So we know that angle DCE and angle ACB are right angles. How did we know that? What told us that? The square told us it, but specifically we see that line AE is perpendicular to line DB, right? So we're going to say that our reason is that's the definition of perpendicular lines. So we know that perpendicular lines form right angles. I'm going to try my best to space this so that we don't run it out. Now I have to tell you something about these. So we see that we have this side is congruent to this side, and we see that this side is congruent to this side. But what are we missing? We're missing showing what part? That our two angles on the inside are congruent. What do we know about them? We know that they are right angles. And by one of those theorems we had in chapter 3, we know that all right angles are congruent. So we can say angle DCE is congruent to angle ACB because all right angles are congruent. Okay, I don't have a lot of space. I'm going to try to fit it in above where we can see it still. But now we have shown that this segment here is congruent to this segment here. That the interior angle or the included angle are congruent. And we also show the other sides are congruent. So how have we shown that these triangles are congruent? By which theorem? Is it side, 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 or side, angle, side? Side, angle, side. So you could just write what we're trying to prove because now we have done it. And we're going to write SAS.